Hello friends, let us discuss about binary numbers. Before that, going into topic, let me ask you a question. So, what is binary number and why we are modifying the binary number? At the end of the video, you would got an idea why we are using different kind of binary number in different places. So, was entirely we can understand. Binary numbers are nothing but only zeros and one. You already know that. So, don't get more confused. I skip next topic. So, types of binary numbers. First type is unsigned binary number, which means it has no negative sign, only positive signs are allowed. For example, for 4-bit 0 to 15. Likewise, you can add any bit, for example, 0 to 200, that like you can add only positive. But next, we are going to signed binary numbers. Here you want to note an concept of a most significant bit and complement form. So, most significant bit is nothing but the last bit, sorry, first bit, not last, first bit should be 0 or 1 to represent sign. According to most of the cases, 1 is considered as negative and 0 is for positive. Likewise, some cases, some rare cases, it converts into oppositely. For example, 0 for negative, 1 for positive. Don't bother about that. Most of the cases, 0 is positive, 1 is negative. Second method is using 1's magnitude form, 2's magnitude, sorry, 1's complement form, 2's complement form. We discuss about later. And there are 3's complement, 4's complement, 5's complement, etc. We can see later about that. Next, binary coded decimal. It is a simple concept, nothing. If all are using different kind of electronic component. Likewise, we use the electronic component for different purposes. So, the standardization should be required to operate all electronic component in our desired manner. So, in order to accommodate that, binary coded decimal were implemented, which means it consists of 4 equivalent digits, binary digit, from 0 to 9. And from 10 to 15, it is not allowed. The reason we can add a value of 10, 11, 12, that like I will tell later, but using direct representation is not allowed. It is used in calculator, digital clock. We have seen, I will not explain this too much because it will get boring. So, I will go on further concept. This is a general example, calculator and digital clocks. Next, XS3 code. So, XS3 code is nothing. The actual number is added with plus 3. In our language, we say that, for example, if you are given 2, you add 3, it becomes 5. It is used to, XS3 code is used to find the nines complement easier way by complementing the answer of XS3 and taking its equivalent. We see further classes. Now, just to say what is XS3 code and why we are using XS3 code is used for error correction and detection. XS3 code doesn't allow some particular value. If we encounter the value, then we can assume that XS3 code has error. Next, gray code. Why error? XS3 code is used to detect error. Similarly, gray code can be also used to detect error. So, what is use of XS3 and gray? You have little confusion. So, I will explain with a small example, but it not actually work as it is, but you can understand why gray code is used. For example, you take a TV remote. You have increasing, first I will say what is gray code, then I will explain it. Gray code means the bits only changes with respect to one position. So, not changes entirely. For example, if you are given 0, 0 in the video, you can see 0, 0, 0 and 1 bit only changed 0, 0, 1. And again we see only 1 bit changed 0, 1, 1. Again we see 0, 1. The last bit has changed 0. Likewise, gray code changes only 1 bit. It is used in our, for example, it is used in our TV remote. If you want to increase an volume, what will you do? Just simply pressing till you reach the desired volume. So, you will not reach very faster. For example, if you want to increase the volume to 15, in remote you press 11, 12, 13, 14, 15, then only you reach until you can't reach. So, the speed becomes more increasing compared to other type of codes. So, without any boring concepts, I explain very shorter. Gray code used in rotatory and position sensor for robotic arms, etc. to move in bit by bit change, only 1 bit change. So, error can be reduced. BCD means 7-segment display. You have seen, for example, you have seen a watch. It looks like 8 number digit. So it is an example of BCD, which can we change the lighting according to the number. So 2's complement. 2's complement nothing but used in computers processor for addition and subtraction purpose. XS3. XS3s are used in older days. Now itself also using in order to detect any errors.